Hi, welcome to developing distributed applications using Zookeeper. This lesson will provide you with an introduction to Zookeeper. After completing this lesson, you should be able to describe distributed systems and the purpose of Zookeeper, describe the Zookeeper consistency guarantees, describe the basics of Zookeeper components, and describe the application of Zookeeper in the Hadoop ecosystem and usage in other real-world scenarios. A distributed computer system consists of multiple software components that are on multiple computers but run as a single system. The computers that are in a distributed system can be physically close together and connected by a local network, or they can be geographically distant and connected by a wide area network. The goal of distributed computing is to make such network work as a single computer. Distributed systems offer many benefits over centralized systems. One benefit is that of scalability. Systems can easily be expanded by adding more machines as needed. Another major benefit of distributed systems is redundancy. Several machines can provide the same services, so if one is unavailable, work does not stop. Additionally, because many smaller machines can be used, this redundancy does not need to be prohibitively expensive. Distributed applications require coordination. You could develop your own coordination service, however, that can take a lot of work and is not a trivial task. The alternative is using a robust coordination service that is already available for use. Zookeeper is just that, a distributed, centralized coordination service that is open source and ready for use. The Zookeeper service can be used to help you tackle many of the common challenges distributed applications face. Zookeeper can be used to maintain configuration information. For example, you can store configuration data in Zookeeper and share that data across all nodes in your distributed setup. Zookeeper can be used for naming. An example is using it as a naming service, allowing one node to find a specific machine in a cluster of thousands of servers. Zookeeper can be used to solve the problem of distributed synchronization, providing the building blocks for locks, barriers, and queues. Zookeeper can also be used for group services, such as leader election and more. Zookeeper provides the building blocks for all of these scenarios and is distributed, reliable, and fast, while still being relatively simple to work with. In a distributed Zookeeper implementation, there are multiple servers. This is known as Zookeeper's replicated mode. One server is elected as the leader, and all additional servers are followers. If the Zookeeper leader fails, then a new leader is elected. All Zookeeper servers must know about each other. Each server maintains an in-memory image of the overall state as well as transaction logs and snapshots in persistent storage. Clients connect to just a single server. However, when a client is started, it can provide a list of servers. In that way, if the connection to the server for that client fails, the client connects to the next server in its list. Since each server maintains the same information, the client is able to continue to function without interruption. A Zookeeper client can perform a read operation from any server in the ensemble. However, a write operation must go through the Zookeeper leader and requires a majority consensus to succeed. Zookeeper may also be run in standalone mode. In this mode, only a single Zookeeper server exists. All clients connect to the Zookeeper service via this one server. You lose the benefits of replicated mode when using standalone mode. Trading high availability and resilience for a simpler environment can be useful for testing and learning purposes. Zookeeper provides us with 6 consistency guarantees. The first Zookeeper consistency guarantee is that of sequential consistency. This means that updates from a client to the Zookeeper service are applied in the order they are sent. Next, the atomicity guarantee means that updates in Zookeeper either succeed or fail. Partial updates are not allowed. The single system image guarantee states that a client will see the same view of the Zookeeper service regardless of the server in the ensemble that it is connected to. The reliability guarantee means that if an update succeeds in Zookeeper, then it will persist and not be rolled back. The update will only be overridden when another client performs a new update. Finally, the timeliness guarantee means that a client's view of the system is guaranteed to be up to date within a certain time bound, generally within tens of seconds. If a client does not see system changes within that time bound, then the client assumes a service outage and will connect to a different server in the ensemble. In the previous slide, we looked at the consistency guarantees that Zookeeper makes. It is important to understand that Zookeeper does not make a simultaneously consistent cross-client view guarantee. This means that Zookeeper does not guarantee that different clients will have identical views of Zookeeper data at every instance in time. Network delays and other factors may make it possible for one client to perform an update before another client is notified of the change. The way we can handle this is using the sync method that Zookeeper provides. The sync method forces a Zookeeper ensemble server to catch up with the leader. The distributed processes using Zookeeper coordinate with each other through shared hierarchical namespaces. These namespaces are organized much like the file systems in Unix or Linux. Each namespace has a root node and can have one or more child nodes. Since the term node has so many different connotations, Zookeeper refers to each of these nodes as Z-nodes. Data can be stored in a Z-node. When data is written to or read from a Z-node, all of the data is either written or read. Also, there is an access control list, also known as an ACL, that is associated with each Z-node. This allows control over who can create, read, update, and delete a Z-node. As new versions of Hadoop are released, Zookeeper is being used more and more in the Hadoop infrastructure. HBase uses Zookeeper for master election, server release management, bootstrapping, and coordination between servers. Later versions of Hadoop are using Zookeeper to provide high availability for the resource manager. In IBM's Big Insights, Zookeeper can be used with adaptive MapReduce. Apache Flume also has been using Zookeeper for configuration purposes in recent releases. A variety of companies are using Zookeeper with their distributed applications. Twitter, Yahoo, and many others are using Zookeeper for different purposes such as configuration management, sharding, locking, and more. You have now completed this topic. Thank you for watching.